Hi, all. This is guided practice 9. We're in section 2.7 on quadratic inequalities, and we are jumping right into number 2 since there was a separate video for number 1. We are solving, in this case, actually a cubic inequality, which is going to go exactly like our quadratics. So, step 1 would be to say, are there any values here that we can't have? There are no denominators here, so there's nothing we're going to exclude. And then we're going to go ahead and jump into part step 2 here, and that is to solve this as if it were an equation. So x cubed plus 2x squared minus 4x minus 8 equals 0. And from here, we're going to solve that. With cubics, we can only factor, right? And we only have two options when we factor. One is if there's two terms, we're going to look at a sum or difference of two cubes. And in this case, because we have four terms, we're looking to factor by grouping. So that means I'm going to look at the first two terms together and then the second two terms together. And I'm going to factor out what they have in common. So if I look at the two terms in yellow, they both have a common x squared, and I'm going to pull that out. And that's going to leave me with an x plus 2. If I look at the blue, I want to pull out a 4, but if I pull out a 4, it's going to leave me with negative x minus 2, and that won't match what's in my first set of parentheses. So we're going to pull out a negative 4, and that will leave me with x plus 2, and that does match because that's what I'm looking for in factor by grouping. Because now those two terms, remember, terms are things that are added or subtracted. So I have two big terms here. They both have an x plus 2 in them, and I can take it all the way to the front. That leaves me with an x squared minus 4. And I want to take one more step in factoring and factor that x squared minus 4 into a difference of two squares. So x plus 2, x minus 2. And then we're solving each of these pieces. So setting each one equal to 0. What will make each piece 0? Well, x equals negative 2. If you set it equal to 0, you'd subtract your 2 to the other side. X equals negative 2 and x equals 2 are all solutions here. Now, something to note here is that our inequality is or equal to. So that means that all of the solutions that I find here are solutions in and of themselves. Okay, so negative 2 and positive 2 are both solutions to this inequality. If it were greater than, strictly greater than, these would not be solutions, and this is only going to split up my intervals. Okay, but those happen to both be solutions. So now I'm going to go ahead and put those two numbers on a number line. And I'm going to test numbers that are in between. So I'm going to test a negative 3, 0, and 3 so that I know which of these sections works in my original inequality. So I'm going to test those right up here in this original one. So we're plugging it into the purple. So when I plug in a negative 3 and I cube it, negative 3 times itself 3 times is negative 27. For 2x squared, my negative 3 squared would be 9, and then we multiply it by the 2. So 9 times 2 is 18. Minus 4x. So I'm taking negative 3 times a negative 4, and that's positive 12. And then minus 8. And the question is that greater than or equal to 0? If I take the 18 and the 12 and add them together, that's 30. 30 plus negative 27 is positive 3. 3 minus 8 is negative 5. And so that's just not a true statement. And that means that first interval does not part of our solution. That was for x equals negative 3. Next, we're going to check x equals 0. When I plug it into any x term, it's going to make that term disappear. And so that means I'll be left with negative 8 greater than or equal to 0. Again, that's not true either. So that middle section is not an option either. And then we're going to plug in x equals 3. Hopefully this one works. 3 square cubed would be 27. Less 3 squared is 9 times 2 is 18. 3 times negative 4 is negative 12. Minus 8. And the question is that greater than or equal to 0? This time, let's look at the negative 12 and negative 8. Together, that's negative 20. Negative 20 and 18 is negative 2. Negative 2 and 27 is 25. That is a true statement, so we do want that last section. Okay, so when we graph our solution now, we're going to put both numbers on there. And remember, we said that both of those answers are solutions because it's or equal to. So I want a closed dot at both points. And then I only want the space that's bigger than 2. And so I want, whoops, don't want to erase it. it's going to look this way. So kind of awkward if you were writing it. Your solution here would be 2, and I would put it in braces because it's a single value, and from 2 to infinity. And that would be your answer. All right, and that's number 2. Then we're going to move into number 3. Number 3, starting out with our first thing we have to check, which is, are there any values that don't exist here? And the answer to that is yes. And that's because we have 2 denominators. So 2 denominators means we're going to have to exclude whenever those denominators are equal to 0. So we're going to go over here to the side, and I'm going to put them in red so I know that they're not good answers. And we're going to say, I want to know when x minus 2 is equal to 0. So if we add the 2 to the other side, that's when x equals 2. And then if we take the other denominator, which is x plus 1, and set that one equal to 0, subtract your 1 to the other side, that gives you x equals -1. Now I have 2 values that are not solutions. Okay, so 2 and -1 are just not solutions. No matter what happens, 2 and -1 are not solutions. Okay, so we're going to keep that for later. Now I'm going to go through and do step 2, which is to do exactly what we've been doing, which is to change this to an equal sign and solve. So we have 1 over x minus 2 equals 3 over x plus 1. To solve that, we're going to go ahead and clear our denominator. So we're multiplying both sides by x plus 2, sorry, x minus 2, and x plus 1. X minus 2, x plus 1. Okay. Now, when I multiply on each side, on the left, the x minus 2's will cancel, and on the right, the x plus 1's will cancel, which is exactly what our plan was. Now, on the left, I have x plus 1 times 1, and that's x plus 1. And on the right, I have 3 times x minus 2. That gives me x plus 1 equals 3x minus 6. Now, I want my x's on the left and my numbers on the right. So we're going to go ahead and subtract 1 and subtract 3x. When we do that, we have a -2x on the left and a -7 on the right. I can go ahead and divide both sides by -2 to get x equals positive 7 over 2, which happens to be 3.5 for reference. Now this one we know is a solution because again, it's or equal to, and we set it equal to and solve. So 3.5 does work here. Question is, what are some other values that work? So what we're going to do is we're going to take our interval here and we're going to break it at all 3 places. So I have 2 solutions that are 2 points that are not solutions and 1 point that is a solution. And those 3 numbers are going to break up our number line. So we're going to have a -1, 2, and our 3.5 or our 7 halves. We're going to test each of those intervals. So we're going to be testing -2, 0, 3, and 4 and see what happens. So for x equals -2, and again, we're plugging into the original one. So all the way back here, I'm going to put it in purple again. We're plugging in there. So that's 1 over -2 minus 2 greater than or equal to 3 over -2 plus 1. That gives me -1 over 4 greater than or equal to 3 over -1. So -1/4 greater than or equal to -3. And that is a true statement because -3 is more negative than -1/4. And so it is smaller. And therefore that one works. Now, when we plug in 0, we get -1/2 is greater than or equal to 3 over 1. So -1/2 greater than or equal to 3. That one's not true. So we don't want that one. Then we want to check x equals 3. So that's going to give you 1 over 3 minus 2 is 1, greater than or equal to 3 over 3 plus 1 is 4. So that's 1 greater than or equal to 3/4. That's a true statement. So I want that section. And then x equals 4. We are plugging that in and we're going to get, let me get it on the screen. There we go. 1 over 4 minus 2 is 2. Greater than or equal to 3 over 4 plus 1 is 5. So is 1/2 greater than or equal to 3/5? If we're not sure, we can clear our denominators here. Multiply both sides by 10. And that's going to give you 5 is greater than or equal to 6. And that's not a true statement. So we don't want that section. And when you multiply by 10, make sure that you clear, that gives you 30 over 5, which is 6, and 10 over 2, which is 5. So we're just plugging in. And that's going to give us a final answer here. So when I set up my answer number line, I'm putting down all three values. So -1, 2, and our 3.5, which is 7/2. Okay. Now we know that the 2 and the -1 are not solutions. So I'm going to go ahead and put open circles there. We can't have those as solutions. But this was or equal to, and so our 3.5 is a solution. So I want a colored in dot on that one. Okay. Then I want the very interval on the left. So I want this one. Okay. Less than -1. And then I want the one between 2 and 3.5. So I want these two. And so my intervals here are from -infinity to -1, but don't include -1. And then we're from starting from 2, but not including it, and stopping at 7/2, and we are including it. And so that is my final answer. And lastly, we have number 4. Similar setup with this one. So, well, first thing, step one, we've got to see, are there any values that don't work here? And that means we're checking our denominators. So 3x minus 5 and x minus 1. So 3x minus 5 equals 0. Add your 5, divide by 3. That's going to give you 5 over 3. That's 1 and 1/3, or 1.3 repeating. Then we've got x minus 1 equals 0. Add your 1 to the other side, and that's going to give us x equals 1. Okay, and remember, these are our no solutions, or not solutions. Then on to step 2, we're going to go ahead and rewrite our inequality as an equation. So x over 3x minus 5 equals 2 over x minus 1. And we're going to solve it. And we're going to solve it by clearing our denominators. So we're going to multiply both sides by 3x minus 5 times x plus 1. Sorry, x minus 1. Let me fix that. Okay, now when we go ahead and multiply, our 3x minus 5 will cancel on the left, and our x minus 1 will cancel on the right. When we multiply this out, then you'll have x times the x minus 1. And on the right, you'll have 2 times 3x minus 5. From here, we're going to distribute. So x squared minus x equals 6x minus 5. Nope, minus 10. 2 times 5 would be 10. There we go. Now we have something that's quadratic because we have an x squared here. So we're going to move it to the left. So everything gets moved to the left so that we get 0 on the right. That means we're going to subtract a 6x and add a 10. And that's going to give us x squared minus 7x plus 10 equals 0. Now we have a quadratic that's set up, and we have two options. We can factor, or we can use the quadratic formula. I'm always going to try to factor because I think it's less work. So I have an x squared as my first term, so I have two x's in the first spot of each one. And then I'm looking for two numbers that multiply to 10, but add to -7. So two numbers that multiply to 10 would be 5 and 2. Those do add to 7, but you'd have to make them both negative for them to add to negative and to -7. Then we're going to solve each piece. This is going to give me x equals 5, and this one's going to give me x equals 2. And that gives me 4 points to work with. So I have 5/3, 1, 5, and 2. And so we're going to put those numbers on a number line in order. So let's see, the smallest one is 1, then 5/3, then 2, and then 5. So now I'm going to test point. So I want 0. Oh, that's going to be tricky. Probably 1.1 because 5 thirds is, no, 5 thirds is 1 and 2 thirds. Well, let's change that. 5 thirds is 1 and 2 thirds, and 2 thirds is 0.66 repeating. So we could use 1.5 there. Let's see. Between that and 2, we're gonna have to go with something like 1.8 maybe, or 1.75. And then I'm gonna go 3 and 6. So for x equals 0, you're gonna have 0 over -5 is less than or equal to 2 over -1. And that's 0 less than or equal to -2. And that's not a true statement. So we don't want the first one. For x equals 1.5, you're going to have 1.5 divided by, let's see, 3 times 1.5 is 4.5. 4.5 minus 5 is 0.5. And then we'll have less than or equal to 2 over 1.5 minus 1, and that's also zero point 0.5. And if you multiply both sides by 0.5, that'll give you 1.5 less than or equal to 2, and that is a true statement. So we'll take that one. Next, x equals 1.8. Let's see, 1.8 divided by 3 times 1.8. So that's like 3 times 18. So that is 30 plus 24. So 54. So 5.4 minus 5 is zero point 0.4 on the bottom. Less than or equal to 2 over 1.8 minus 1 would be zero point 0.8 on the bottom. If we multiply everything by 0.8, you could also just divide those in a calculator if it's easier for you. I just don't have one handy. That's going to give us 3.6 less than or equal to 2, and that is not a true statement. So nope on that one. Next, our interval is in our next interval, we've got x equals 3. And we're plugging that one in. So 3 over 9 minus 5 is 4. Less than or equal to 2 over 3 minus 1 is 1. So is 3/4 less than or equal to 2? It sure is. So we want that one. And lastly, x equals 6. We will have 6 over 6 times 3 is 18. 18 minus 5 is 13. Less than or equal to 6 over 5. Sorry, 2 over 5. And let's see. We would need to multiply this by a number that would clear the 13 and the 5. So that's gonna be 65, I think. And when we do that, we're gonna get 30 is less than or equal to 26, and that's not true. Again, you can just plug those into a calculator and see what they come out to be. 2 over 5 is 0.4, and 6 over 13 is going to be something bigger than that. And so we're going to end up here with no on that last interval. So our answer here, we're going to put on all of our values. So again, we've got the 1, the 5 thirds, the 3, and the 5. Now we know that the 5 thirds and the 1 are not values. And we know that the 3 and the 5, check it, it is or equal to. So 3 and the 5 is a yes. Oh, hold on, that's a 2, not a 3. Oops, let's fix that. Okay, and then what we want is we don't want the first interval, but we want the second. So we want it the one between these two. We want to skip over the third, but we do want the fourth. And so that means you have two intervals here. You have from 1 to 5 thirds, but you're not including either of them. And you have, whoops, hold on, that erased. And you have from 2 to 5, but you're going to include both of those. So using our square brackets on that one. And that is your final solution for number 4.